Very good morning. Today we are going to solve a problem in star connected network which is connected to a AC supply. Take down this a balanced three uh, a balanced star connected load having an impedance of 15 plus J20 ohms per phase is connected to a three phase 440 volts 50 hertz AC supply. Find the line currents and the power absorbed by the load. Assume the RYB phase sequence. So here what they are asking is they are asking to find out the line currents, power absorbed by the load, and also assume the RYB phase sequence is as. And the phasor diagram they didn't mention, but sometimes they'll mention the phasor diagram also. I have explained in this problem the phasor diagram also. That also we'll see. That will be useful for you if they ask phasor diagram also. So here comes the solution. First, from this problem, we need to draw the three balanced star connected network. So what is the impedance it is given? The impedance it is given as 15 plus J20. So here what I am doing is here I am adding the impedance here as 15 plus J20, and here also 15 plus J20, and here also 15 plus J20. It is connected to R, Y, and B. Okay, so here the voltage between these two phases V R Y, the voltage between these two phases R phase and B phase is VBR, and the voltage between the Y phase and B phase is VYB. And the current is here IR, IY, and IB. Okay, so we are so what is the phase sequence? R, Y, and B. So we need to assume in the this clockwise direction. Okay, clockwise direction R, Y, B. So this V, R, Y, B, Y, B, 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 R. Now, what we need to find out? We need to find out the line currents. So first, RYB is VL at the angle of 0 degree, because 0 degree means VRY is 0 degree. See here from this diagram, you can clearly know. So VRY is VL. That means VRY is equal VL at the angle of line voltage at the angle of 0 degree. That means line voltage is 440 volts at the angle of 0 degree. Next, VYB. So from this VR to VY, this is minus, because we are going in anti-clockwise direction. So this is minus 120 degrees. So VL at the angle of minus 120 degree. That means VL is given in the problem as 440 volts line voltage. So 440 at the angle of minus 120. Next is a VBR. So VBR. So VBR, what is they ask? So VL at the angle of minus 240 degree. So VL means, so again 440 at the angle of minus 240 degree. So here we can also write here 120, 120. That is minus 120, minus 120. We can also write as minus 240. And also from respect to this VRY, this is plus 120. So you can also write as plus 120. Either way, it is same. Now, we need to find out the what is the phase current, that is our phase current. So phase voltage is equal to, in star connected, phase voltage is equal to 1 by root 3. That is this VRY divided by root 3. Line voltage divided by root 3. So line voltage RY is nothing but 440 at the angle of 0 degree. But here it is 30 degree. So if we are converting this this means so it is a 30 degree lag. That means we are converting this this yeah phase voltage to the line voltage. So that means 30 degree lag. So VRY. So VRY is what? 440 0 minus 30 degrees. So 0 minus 30 is minus 30. So that, like that, that's why I have taken directly minus 30 degrees. So 440 divided by root 3 minus 30 degrees. So if you simplify this, you will get a 254.034 at the angle of minus 30 degrees. That is the VR. Similarly, B y. So Vy is equal to same thing, 440 divided by root 3. So here at the angle of minus 120 degree. So here you see minus 120 degree, minus 30 degree lagging, no? For conversion 30 degrees. So minus so minus 120 degree minus 30 degree. So minus 120 minus 30 degrees minus 150 degrees. So Vy is 254.034 here minus 150 degree. Next Vb. Okay, V voltage at phase voltage, B phase is equal to that is line voltage by root 3. Here minus 240, no? Here you see minus 240 or 120. So you can take minus 240 or 120. So I am taking this 120 minus 30 degree because 30 degree lagging angle. So minus 30 degree. So that is the conversion. So by converting the phase into line. Okay? So 120 minus, so this is the conversion factor, minus 30 degree lagging, so minus 30 degree. So 120 minus 30 is 90 degree. So B phase equal to 254.03 90 degree. So, but the magnitude of the R, By and Bb is nothing but 254.03 because here also 254.03 volts, here also 254.034 volts, here also 254.034. So that is the magnitude. Next line, this is the magnitude of the voltage. Okay, so phase voltage we calculate. Phase voltage. So first they said to calculate the phase voltage. Next we need to calculate the line current. Okay, so line current, for calculating line current, we need a line voltage divided by sorry, phase voltage, that is a magnitude, but this is the line voltage only. So VL at the angle of 0 degree, VL at the angle of minus 120, like that. So a line current is equal to IL is equal to VL divided by Z. Okay, VL divided by impedance Z. So VL divided by, that is simple Ohm's law only. So VL is what that we calculate. Okay, line current, that is 254 point, yeah, 254.034 at the angle of minus 30 degree. So that is that is, say for example, if you calculating for IR, okay, this sorry, this is not line current, this is the um, uh, line current. In star connected, line current is equal to phase current, no? So line current is equal to phase current, IL is equal to IR is equal to VL divided by Z. So here VL VL is what? 254.03 at the angle of minus 30 degree divided by Z. So Z is what? Z is already given in the plot. That means 15 plus J 20. So that's what here we are substituting 15 plus J 20. So again, what we are doing is here this is in complex format. We are converting into polar format. That if you convert into polar format, 25 at the angle of 53.13. Okay, so this two, if you divide, you will get 10.16. So this you can take this side. So minus 30 minus 53 is minus 83.13. Okay. So we are mentioning in polar form. So here IR is equal to 10.16 at the angle of minus 83.13 amperes. Next is IY. Okay, phase current or line current is same. So phase current IY is equal to line current of the yellow phase is equal to Vy divided by Z. So Vy already we calculated. Vy is what? 254.034 at the angle of minus 150 degree. So here we are substituting Vy 254.03 at the angle of minus 150 divided by Z. So Z already we converted, and so 15 plus J into 20 that we converted into polar form, that is 25 at the angle of 53.13. So that we are substituting over here. So this we are simplifying, same answer only will get 10.16 at the angle of, here the angle alone will change. This will go minus because if it is in divide means angle you need to this side, if you taking the numerator denominator numerator, it is minus. So 150 minus 150 minus 53.13 is minus 203.13 amperes. So Iy is 10.16 at the angle of minus 203.13 amperes. Next, similarly, IB. So IB is equal to VB divided by Z. So VB is what? Already we calculated 254.03 at the angle of 90. Okay. 254.03 at the angle of 90 degree divided by this Z already 25 here we converted 25.53 25 at the angle of 53.13. If you simplify, we'll get 10.16 at the angle of 90 minus 53.16 will get 36.87 degree. So that is IB, that is in amperes. Now we are going to calculate what is the power absorbed by the load. Okay, so power absorbed by the load P is equal to root 3 VL IL cos phi. Okay, so IL, so line current is equal to phase current. Okay, all are same. So the magnitude, if you calculate, only it will come like 10.16 amperes. Okay, so phase angle alone it will changes already. That already we calculated IR, IY, and B also is that. So power absorbed with root 3 BL IL cos phi. So cos phi. So phi is what? So phi is 53.13. Okay, so phi is yeah, here. So cos phi is 53.13 because if you convert this 15 plus J20, if you convert that, the angle is 53.13. So that is this cos phi angle. So cos 53.13. Okay, so P is equal to root 3 into VL is what? VL is 440 into IL is what? So IL, line current, we calculated 10.16, that is this is in magnitude of the line current, 10.16 cos of 53.13. So if you multiply this, you'll get the answer as 4645.787 watts. So if you convert into kilowatts, it is coming as P is equal to 4.64 kilowatts. Now we are drawing the phasor diagram for this. So even though phasor diagram is not some problems they might be asking. Okay, so assume the RYB phase sequence, draw the phasor diagram. So phasor diagram now we are drawing. So VRY, we are first VRY, VYB and VBR. So between the VRY and VYB, the angle is minus 120 degrees. The thing which marked in black color. Okay, black color around you take. So this is also black color. So VRY, sorry, blue color. So this is a blue color, no? So VRY with respect to VYB is nothing but the angle is minus 120 degree. Again, VYB with respect to VBR, because clockwise direction I said, no? So again it is minus 120 degree. Okay, minus 120 degree. Next, this VRY with respect to VBR is minus 240 degree. Okay, so this whole thing is 240 degree, or otherwise we can write it as 120 degree also. This already we have seen. Okay, so yeah, 120 degree or minus 240 degree or 120 degree. So 120 degree we mark. So with respect to our VRY, this is 120 degree. So we marked VRY, VYB and VBR. Now we are marking this this one phase voltage VR, VY and VB. So VR is what we calculated. Phase voltage VR we calculated as 254.034 at the angle of minus 30 degree. So minus 30 degree. It is lagging by angle of minus 30 degree. So minus 30 degree means with respect to this, it is minus 30. So here it is VR. So it is minus 30 degree, which is marked in pink color. No, that is mine. So Vy, so it is marked in orange color. So Vy, what is the answer we got? Vy is minus 150 degree. That is the answer we got. Okay, minus 150 degree. So now we are marking from here to here 150, because from this point to this point 120 minus 120, again one minus 30 degree also adding, because then only it will come minus 150, no. So but this angle alone minus 30 degree, the whole angle is minus 150 degree. So Vy is minus 150 degree. Next Vb is plus 90 degree. So Vb is so here I am marking Vb here. So plus 90 degree with respect to this particular R phase. Okay. So now we mark Vr, Vy and Vb. Now we need to mark what is the current. Current also we calculated, no? IR, Iy and Ib. IR, Iy and Ib, because we calculated, yeah. So we calculated here IR is what? IR is minus 83.13. Iy is minus 203.13. Next, IB is 36.87 degree. So first is IR is how much? Minus 83.1 degree. So minus 83.13 is approximately, because up to this is 120, no, approximately 83 is coming here. So this is, we are marking this as minus 83.1 degree, that is IR. Now Iy is what? Iy we calculated as minus 203.13. So minus 2. So from here, so up to here is 120. Okay, and this is 240. So approximately minus 203.13 is approximately this. So that is Iy is minus 2. So from here, the brown color, no, it is marked in brown color, no, from here to here, approximately it is minus 203.1 degree. If you use the protractor, you can exactly mark okay, minus 203.1 degree. But I taken just randomly, because up to here 120. So from here to here 240. So randomly I have taken this as minus 203.13. Like that I have taken. Next, IB is 36.87. No, so 36.87, that is IB. So 36.87. So that is approximately 36.9. So from here to here, okay, because this is IB in this direction, no? So from here 36 plus 36.9 degree. So approximately plus 36.9 degree. See, because here is 90 degree, means here approximately I'm marking it as 36.9 degree. That means IB. So this is how you need to mark. So, and also in the problem clearly given is assume RYB phase sequence. So RYB, that phase sequence only we followed in this question also. So this is how you need to draw the phasor diagram for this this RYB star connected balance three phase system. So three phase system.